In this beaker, we have some zinc sulfate. In this beaker, we'll have copper sulfate. To put the ions into solution, we'll simply dissolve them in some distilled water. I'm going to place a strip of zinc metal into the copper sulfate solution and the strip of copper into the zinc sulfate solution and wait and see what happens. After a very short time, it seems apparent that the copper has no reactivity in the zinc solution, but that the zinc has reacted with the copper. The black you see there are microscopic crystals of copper. Some larger crystals have formed up here, giving it a copper color. The reason for this is when zinc is placed in copper, the zinc oxidizes and the copper ions reduce. Zinc goes from being 0 to +2 by losing 2 electrons, and the copper ions go from being +2 to 0 by gaining 2 electrons. To accomplish this, what you need to do is put the zinc and copper into 2 different containers. Don't put the zinc directly in the copper, or the electrons are going to make the transfer right in this beaker. Instead, put the zinc in to this beaker with the zinc sulfate, and put the copper in with the copper sulfate. Metals do not react with their own ion. There's actually no potential difference between zinc and zinc +2 ions, so no reaction will occur in those beakers. If we take a wire and place it on the zinc strip, take that wire and connect it to the negative terminal of our load, in this case a voltmeter. Then we hook the copper up to the positive terminal of our voltmeter. Now apparently there's nothing happening. Our voltage is still 0. And the reason is because we have an external circuit, wires, but we need an internal circuit. We need to complete the circuit by connecting the 2 solutions. For this we need a salt bridge. Watch the voltmeter as the salt bridge is placed between the 2 solutions. Aha! Look what we have here, ladies and gentlemen. We have ourselves some voltage. This is the anode. The anode is where oxidation takes place. This is the cathode. This is the electrode where reduction takes place. The anode and cathode refer to the metal strips that the wires are connecting onto. This is called the anode half cell. And this is called the cathode half cell. And together, these 2 half cells form a voltaic cell. Now, if you want to make a battery, what you do is you hook up a whole bunch of these in series. In other words, we'd hook up the zinc of one cell to the copper of this cell, and we'd just keep going and going and going in series. The more cells you have, the more voltage you're going to get.